Okay. Okay, now let's move to the task B. So task B is actually the crux or the main part of the lab. So here what you are going to do is that you are going to implement this pseudocode, and how you are going to do that, let me show you the skeleton. So actually you need to do to complete the missing parts which are indicated by to-dos. So the task one, you only need to do the to-do one, but for the task B, you need to do the to-dos number from 2 to 11. 2 is in .ini file, and remaining like 3 to 11, they are in the .s file, right? So what you need to do is to do 2 is simple. You only need to call the read input function, and this function is basically defined in the uh, you need to call the read let me give it the correct name. The name is not correct. The name should be this one, read input and control LEDs. So let me just put it here so that you don't look for the wrong function name. Okay, so you just need to call this function, that is to do 2, and to do 3 is that you need to set PB0, with which your green LED red LED connected, PB4 has green LED connected, and PB5 has yellow LED connected. So you need to set the pin 0, 4, and 5 of port B, which are basically pin D8, D12, and D13 on the Arduino board. You need to configure them as in output mode, but using bit manipulation instructions. And this is crucial. You must follow the bit manipulation instructions, which is like in this lab. And by those instructions, I mean set bit SBI instruction, CBI instruction, SBIC instruction, and SBIS instruction. And these instructions we have covered in the lecture slides. So if you don't understand what I mean, go back and watch the lecture recording and go through the slides, right? So you need to set these pins in the output mode, and then you need to set the PB1 pin, which is basically the D9 pin on Arduino board, and we have connected our push button. You need to configure this pin in input mode. Okay, then you also need to enable the internal pull-up register on PB1, pin 1 of the port B. And for all these operations, you must use bit manipulation instructions. Otherwise, if you write the full register of a port, it will not be counted correct. Then after doing that, first you need to do is that you need to test that all three LEDs are working by sending logic high to them. So what you need to do is that just configure these PB0, PB4, and PB5 as output pins, PB1 as input pin, enable the internal pull-up resistor on PB1, and then send high signal to all the three LEDs by using the bit manipulation instructions. And this is only for testing purpose, first to make sure that our LEDs are working fine. Then what you need to do in 2 to 7 is that undo 2 to 6, which basically mean that comment the code which you have written to complete the task 2 to 6. So comment that code, and then uh, we are calling a function called wait 500 millisecond. And then after that, what you need to do is like uh, you need to write the code here. You need to write the code which actually does the following: that when the push button is pressed for the first time, it switches on the red LED. So basically, it means that it senses the input and checks that if the input is 1, then it sends, sorry, if the input is 0, remember our push button is active low. So when we press the push button, the input is 0. So we need to write a code here for this to do that if the input is 0, then our red LED should be switched on, right? And then again, we wait for 500 millisecond, and we move to do 8, where we actually monitor and sense the second push of the button. And if it is pushed for the second time, our green LED should be switched on. Again, we wait for 500 millisecond, and we wait for the third push, and when we sense the third push, we switch on the yellow LED, and again we wait for 500 millisecond, and we wait for the fourth push. And when we sense a fourth push of the push button, then we switch off the red LED. This is important. Now first we turned on, switched on all of them one by one. Now we are switching off all of them one by one. So on fourth push, we switch off the red LED, then wait for 500 millisecond. Then on fifth push, we switch off the green LED, then wait for 500 millisecond, and then on sixth push, we switch off the yellow LED. And then we are like go back and go back to the start of the loop, right? So this is what we need to do. Now let me pause the recording, and then I will come back and show you how it should look like on your hardware. Okay. uh, Okay, so now I have burned my code of the like completed lab on my microcontroller, and now you can see that it should be doing what it is supposed to do. So if you can see I hope you can see the LEDs. Not right now, no LEDs on, and if I push the first button, so the red LED is on. Then if I push the button again on the second push, green LED goes on, and on the third push, the yellow LED goes on. If now I push the button again, the red LED goes off. Then on the fifth push, our green LED will go off, and then on the sixth push, yellow LED will go off. And if I push it again, now again my red LED will go on, and then green one, and then yellow one, and again if I push, so you can basically see now the red is off. Now you basically see that the code is executing in an infinite loop. So basically I am reading the input from the push button after delay of every 500 millisecond, and then taking the action based on that, right? So your then when you are done with this task, show your task to the TAs, and if they have any questions, answer those questions, and then get your work credit. Yeah, so good luck with this lab. See you in next lecture.